All right, question B. Okay, again, we can move the -12 to the other side. Then we have x plus 3 squared equals 12, right? And then if you have something squared is 12, that means b plus 3 is positive or negative square root of 12, which is positive or negative twice of square root of 3, right? And then you can solve v is actually -3, positive or negative twice of square root of 3. Okay, next question. X squared plus 9 is 0, right? And if we put 9 to the other side, 9 becomes -9. And we can solve this equation in the complex number set. That means x is positive or negative 3i, right? Remember that you can always verify your result. If x is positive or negative 3i, then x squared is 9i squared, right? I is the imaginary unit, which means I squared is -1. So x squared is -9. Okay, and question D. Okay, this time we have z plus 3 squared is -9. And then we know that z plus 3 must be positive or negative 3i, right? Because for positive or negative 3i, its square is -9. So that means z is -3, then positive or negative 3i. Okay. Any questions regarding the question 1? Any question? No? How about Cora? Okay. All right, let's have a look at question 2. Find the solutions to the equation x squared plus 2x minus 7 is 0. Okay, we can find the solutions using completing the square method. Remember that we have learned the formula here. The squared sum of a and b is actually a squared plus 2ab plus b squared, right? And this is actually our a squared, and 2x is our 2ab. And as long as we can find our b squared, we can then use the formula, right? Okay, so that means 2ab is 2 times x times 1, right? X is a, then 1 is b, right? So we need another term, which is 1 squared. So x plus 2x minus 7 is 0. This is equivalent to, in order to use a formula like this, you need to add another term, which is 1 squared, right? And then you will have a squared plus 2ab plus b squared, right? A is x, b is 1, right? And note that there is no 1 squared in the original equation, so you need to subtract it in order to make the new equation equivalent to the original one. Then copy the rest of the terms, which is minus 7 is 0. Okay, so this is equivalent to, okay, for the first part, we can use the formula. This is actually x plus 1 squared, right? And then minus 1 minus 7, which can be put in the other side, which is 8. Can you follow me? Then this is equivalent to, if something squared is 8, then something inside brackets must be positive or negative square root of 8, which is actually positive or negative twice of square root of 2, right? And this is equivalent to x equals, you can just put the positive 1 to the other side, which is -1, negative or positive or negative twice of square root of 2. Okay, any questions? This is called the completing square method. Completing the square. Okay. All right, no questions? Then we move to the next one. Okay, third question. Solve the quadratic equation x squared plus 8x equals 14. Okay, again, we can use this formula to complete the square on the left. So on the left, we have x squared plus 8x, right? So we can regard 8x is or 2ab. Then a, because a is x, so 8x can be rewritten as twice of x and then times of 4, right? Then this is 2ab, right? A is x, then b is 4, right? So original equation x squared plus 8x equals 14. This is equivalent to, we need to add a term which is 4 squared, right? Because this is a squared plus 2ab plus b squared. Then note there is no 4 squared in the original equation. So we need to subtract it. Then equals, copy the rest of the equation here. Okay, so this is equivalent to, okay, now for the first part, this according to the formula, this is x plus 4 then squared, right? Remember that you can always verify this. If you expand it, this is x squared plus 2ab, which is 8 squared plus 16, which is the first part of the equation, right? And then minus 16 equals 14, right? And then we can put the minus 16 to the other side. So this is x plus 4 squared equals 30, right? Okay, so this means x plus 4 must be positive or negative square root of 30. Then we can solve our x. X is actually minus 4, positive or negative square root of 30, right? This is our two solutions for the equation. Okay, please have a look at this. Any questions? Again, we have used the completing square method. No questions? All right, let's have a look at the next one. Okay, next one, again, we can use completing square method, right? So usually, if the coefficient of the term with highest order in the quadratic equation is not, if this is not 1, we can divide both sides using 3 here to let the coefficient be 1, right? Okay, so the original equation is equivalent. If you divide both sides using a 3, then we'll have x squared plus 4x plus 1/3 is 0, right? Note that if you divide both sides using a number that is not 0, you did not change the solutions of the original equation, right? So that's why we can use the equivalent symbol here. And then this is our a squared. This is our 2ab, right? So 4x is actually twice of x and then times the 2, right? So 2ab, a is x, then b must be 2, right? So in order to use this formula, write it here again. A plus b squared, which is a squared plus 2ab plus b squared. In order to use this, we need to add a term, which is b squared, right? So we can add a term, which is, remember the other term is 2, right? So 2 squared. Then there is no 2 squared in the original equation. We need to subtract it from the equation, right? In order to make it equivalent. Then copy the rest of the equation. All right, next. First part now is a completed square, which is x plus 2 squared, right? X plus 2 squared is x squared plus 4x plus 4, right? And then minus 4 plus 1/3 equals 0. And this is equivalent to x plus 2 squared. And then we can move these two constants to the other side, which is 4 minus 1/3, right? And this is equivalent to x plus 2 squared equals 11/3, right? And x plus 2 now must be positive or negative square root of 11/3, right? These are the solutions of the original equation. So this means x is minus 2 positive or negative square root of 11/3. And usually we'll need to rationalize the denominator. So x is negative 2 positive or negative square root of 33/3. Okay, please have a look at the solution here. Any questions? Please let me know, okay? All right, if you don't have any questions, let's have a look at question 5. There are 4 questions. Solve each of the following questions by completing square. Okay, again, we're using completing the square method to solve each of them. For the first one, in order to use the method, you need to add a term, right? We have a square and then 2ab. We need b squared, right? So 2ab is 2x. Apparently 2x multiplied by 1, right? So the other term must be 1 squared. Okay, so original equation is equivalent to x squared plus 2x. We need to add a 1 squared, right? Note that there is no 1 squared, so you need to subtract it in order to make the new equation is equivalent to the original one. And then copy the rest of the equation. Then this is equivalent to, first part now is x plus 1 squared, right? And then 13 minus 1 is 12. Then x plus 1 squared is negative 12. So now we have something squared is negative 12. We need to solve this equation in the complex number set, right? So that means x plus 1 must be positive or negative I times square root of 12, right? Because positive or negative I times square root of 12, if you square it, you will get negative 12. Okay, that means x is negative 1, positive or negative 2i square root of 3. Any questions? For question A, any questions? No? All right, let's have a look at question B. Okay. First of all, let's rewrite the equation like this. 12r squared minus 11r minus 36 equals 0, right? And usually, if the leading coefficient is not 1, we can divide the leading coefficient to both sides. So this is equivalent to, we can divide both sides using the 12, right? So this is r squared minus 11 over 12r, and then minus 3 equals 0, right? And then again, you need to use this formula. A plus b squared is a squared plus 2ab plus b squared. So apparently here, minus 11 over 12r is our 2ab, right? So 2ab is minus 11 over 12r. And then we know a is r, right? So a is r. So what is b? If you divide both sides using 2, you will get minus 11 over 24r, right? So b must be 11 over 24. Then let's add another term, which is 11 over 24 squared, right? And then this is a squared minus 2ab plus b squared, right? And because there is no this term, we need to subtract it in order to make the new equation is equivalent to the original one. Then copy the rest of the equation. All right, so from now on, the first part can be rewritten as r minus 11 over 24 squared, right? And remember, you can always verify a result. If you verify that, this is r squared minus 2ab. So 2r times 11 over 24, which is 11 over 12r, which is term in the middle, right? And then 11 over 24 squared. So this is exactly the same as the first part of the equation above. So that means completing square method here is correct. Then minus 11 squared is 121, and 24 squared is 576, right? And then minus 3. So here we rewrite 3 using the common denominator, which is 576. And 576 times 3 is 0, right? Okay, next step, r minus 11 over 24 squared. Then we put all the constants to the other side, which is 576 is the denominator. Numerator is 121 plus 576 times 3, which is, if we add them up, you will get 1849, right? Over 576. Okay, so 1849 happens to be a perfect square number, right? Which is 43 squared. You can verify this. 43, 43, 9. Then 1849, right? Okay, so that's a good thing. All right, so basically we have something squared, which is a perfect square number. So that means r minus 11 over 24 must be positive or negative square root of 1849 over 576, which is positive or negative 43 over 24. Remember, 24 squared is 576, right? Okay, now we can solve our R. R is 11 over 24, negative or positive or negative 43 over 24. And therefore, R is, if we choose the positive sign here, this is 54 over 24, which is 9 over 4, right? Or if you choose the negative sign here, this is R equals negative 32 over 24, which can be simplified to minus 4 over 3. Oh, our solutions are two. There are two solutions. 9 over 4 or negative 4 over 3. Okay, please have a look at the solution here. And let me know if you have any questions, okay? I'll give you some time to correct your result. Let me know if you finished, okay? There's no tricks. You can just follow the arithmetic rules. All right, okay. If you finished, let's have a look at question C. All right, so we can just follow the same method. First of all, let's simplify this equation. The original equation is equivalent to 14y squared minus 20y and then minus 15y. This is minus 35y, right? And then plus 7 equals 0. And then we can divide both sides using the leading coefficient, which is 14, right? So this is equivalent to y squared minus 35 over 14y plus 7 over 14 is 0. And note that we can simplify this. This is y squared minus 3 over 2y plus 1 over 2 is 0, right? So, oh, sorry, I made a mistake here. This should be 5, not 3. Then we only need to solve this equation, right? And this is our a squared. This is our 2ab. We need another term which is called b squared, right? So apparently 2a, which is y, and then b equals 5 over 2y, right? And we can cancel, if we cancel y like this, and b is 5 over 4, right? So we need 5 over 4 squared, right? Okay, so following this cell, this is equivalent to y squared minus 5 over 2y plus 5 over 4 squared, right? And because there is no such term in the original equation, we need to subtract it in order to make the new equation equivalent to the original one, and then copy the rest of the equation. Okay, so this is equivalent to, first of all, the first three terms can be rewritten as a perfect square, which is y minus 5 over 4 squared, right? And if you verify this, this is y squared minus 2ab, which is 5 over 2y, and plus 5 over 4 squared, which is exactly as the equation in the previous step, right? And then copy the rest of the equation, which is 25 over 16 plus 1 over 2 is 32 over 16. And this is equivalent to y minus 5 over 4 squared, and then plus 7 over 16 equals 0, right? Am I correct? Okay, let me check. Oh, sorry. This should be not 32. This should be 8, right? 8 over 16 is 1 over 2. Okay, so this is negative 17 over 16, right? Okay, so this is equivalent to y minus 5 over 4 squared equals 17 over 16, right? And this means y minus 5 over 4 equals positive or negative square root of 17 over 16, right? And now we can solve our y. Y is 5 over 4, and then positive or negative square root of 17 over 16, over 4, right? And therefore, the two roots are y equals 5 plus square root of 17, or y equals 5 minus square root of 17 over 4. Okay, please have a look at the solution. And let me know if you have any questions, okay? I'll give you some time to correct it. And let me know if you finish, okay? Okay, finished? Emily. How about Emily? Okay, let's have a look at the next one. I'm running out of space, so I'll copy this equation to the next page. All right, last equation. Again, we can use the same method, right? Because the leading coefficient is not 1, so usually we'll divide both sides using the leading coefficient to make the equation look a little easier. So we divide both sides using 5. The original equation is equivalent to x squared plus 3 over 5x plus 9 over 5 is equals 0, right? And note that we have a squared, which is x squared, then 2ab. We need b squared, right? So apparently 2ab is 2 times x times b. And this must be equal to 3 over 5x, right? And if we cancel x and then move to the right, then apparently b is 3 over 10, right? Okay, so this is equivalent to x squared plus 3 over 5x. Then we plus 3 over 10 squared, which is b squared, right? And subtract it by this term because it does not exist. And then copy the rest of the equation. And this can be further equivalent to, for the first 3 terms, this is x plus 3 over 10 squared. And then minus 9 over 100 plus 9 times 20 over 100 is 0, right? And this is equivalent to x plus 3 over 10 squared minus plus. This should be 180 minus 9 is 171, right? equals 0. And then this is x plus 3/10 squared is 171 over 100. Should be negative, right? Okay, so this means we have to solve it in the complex number set. So x plus 3/10 is positive or negative I times square root of 171 over 100, right? This means x is negative 3/10, negative or positive 3i times 19 over 10. Okay, any questions? Great, I'll leave you some time to correct your solution. Let me know if you finish, okay? All right, let's see the next one. Okay, question 6. Let A, B, and C be constants where A is not 0. And find formula in terms of A, B, and C for the solutions for x to the quadratic equation ax squared plus bx plus c is 0. So this is a general term of the quadratic function. So this question actually is this question tells us how we can derive the quadratic formula from a general form quadratic equation. Okay, so we can use the same method, which is completing the square. So first of all, we can divide both sides using the leading coefficient a, right? Because it says a is not 0. Therefore, we can use it as a denominator. So original equation, yeah, write one more step. Original equation is a x squared plus bx plus c equals 0, right? And this is equivalent to x squared plus b over a x plus c over a is 0, right? So in order to completing the square, here we have a squared and middle term is 2ab, right? And we need our b squared. So apparently a is x. So 2ab is actually 2 times x times b. And this must be lowercase b over a x, right? And if we cancel x here, the uppercase b is then b over 2a lowercase, right? So this is our b. So apparently this is further equivalent to, okay, I'll write it here then. This is equivalent to x squared plus b over a x, and then we need b squared, right? And apparently b squared is b over 2a then squared. And because the equation in previous step does not have this term, so we need to subtract it from the equation in order to make it equivalent to the original equation. And then just copy the rest of the terms, which is c over a equals 0, right? Okay, now you can see here, the first 3 terms is a perfect square, which is x plus b over 2a squared, right? And if you verify this, this is x squared plus 2ab. 2ab is 2x, and then b over 2a, right? Which is b over ax, which is term in the middle. And then plus b over 2a squared, which is the last term here, right? So that means the completing square method worked here. Okay, so these are the first three terms. And note here, a, b, c are all constants, right? So for the second part, we only have constants. That is minus b squared over 4a squared plus c over a, right? Which is 0. And this is equivalent to x plus b over 2a squared, and then minus b squared over 4a squared, and rewrite the last term using the common denominator, which is 4a squared. And numerator becomes 4ac equals 0, right? And this is equivalent to x plus b over 2a squared equals 4ac, sorry, this should be b squared minus 4ac over 4a squared, right? And this is equivalent to x plus b over 2a equals square root of b squared minus 4ac over 4a squared, right? And our final solution, this should be positive or negative. And then our final solution is b over 2a, positive or negative, square root of b squared minus 4ac over 4ac, right? And if we simplify this, this means x should equal b plus or negative, positive or negative, b squared minus 4ac. Sorry, there is a negative sign here. I lost a negative sign. X equals negative. And then 2a, positive or negative, the absolute value of 2a, right? Remember that square root of 4a squared is the absolute value of 2a, not 2a, not minus 2a, but the absolute value of 2a, right? Okay. Let's rewrite this in another way. So positive or negative, the numerator is square root of b squared minus 4ac, and here we have 2a, right? Okay, so if 2a is positive, that means if a is positive, our solution is x equals minus b, positive or negative, square root of b squared minus 4ac over 2a, right? And if a is negative, apparently our solution is minus b, negative or positive, square root of b squared minus 4ac over 2a, right? So no matter the sign, no matter a is positive or negative, we both have two solutions, which are minus b positive or negative, b squared minus 4ac over 2a, right? So the solution is, no matter what a is, as long as it is not 0, the solution of x is minus b positive or negative, square root of b squared minus 4ac over 2a. So this is called the quadratic formula. So note here, if b squared minus 4ac is positive, then we have two different real roots, right? Because if it is a positive number, the square root of a positive number is also a positive number. Then positive or negative, a positive number makes you two different real roots, right? And the second case is if b squared minus 4ac is 0, that means this part is 0, right? And two real roots are now equal. Both of them are minus b over 2a, right? Then in this case, we have two equal real roots. And third case is if b squared minus 4ac is less than 0, what will happen? That means square root of a negative number. Then this must be a complex number, right? So in this case, we have two conjugate two complex roots which are conjugate with each other. Because their real parts are the same and imaginary parts are opposite, right? You understand? So please remember, do remember this formula here. This is very important. Okay, do you need some time to copy this? Or do you want to make notes after the class? I'll put this onto your Google Classroom, so don't worry. This question only shows you how we can derive the quadratic formula from a quadratic equation. Okay? Any questions? Laura? All right, so let's have a look at how these quadratic equations can be applied to solve a quadratic function, okay? A quadratic equation, okay? And let's have a look at question 7. I'll show you question A first. So this equation is actually equivalent to r squared plus 4r minus 96 equals 0, right? So the first step is to convert this equation in the general form. General form is a form of ax squared plus bx plus c equals 0, right? This is a general form of the quadratic equation. So that means our a is 1, right? And this is our b. B is 4. And this is our c, right? C is negative 96, right? And according to the quadratic formula, the roots of the quadratic equation is denominator is 2a, right? Then minus b, positive or negative, square root of b squared minus 4ac, right? So usually we'll find b squared minus 4ac first. The b squared minus 4ac is 16 minus 4 times a, which is 1, times c, which is minus 96. And this is 16 plus 4 by 96, which is 384. And this is 400, right? Okay, so then x, according to the formula, is minus b is minus 4. And then positive or negative square root of 400, which is minus 4, positive or negative 20 over 2, right? Therefore, when you choose the positive sign here, 20 minus 4 is 16, 16 over 2 is 8. And if you choose a negative sign here, that will get you minus 24 over 2, which is minus 12, right? So here we have two different real roots, which are 8 or negative 12. As I told you before, when this expression here is a positive number, we will have two different real roots, right? Well, this expression here is often called the determinant. That means the value of the determinant determines what kind of roots and how many roots we have. You understand? Any questions? Okay, then I'll leave the rest of the 3 questions for you to correct. Okay, if you haven't done them correctly, please try to correct them after the class. Okay, we'll cover these 3 questions in our next lesson. And before we leave, I'll show you the last question. Okay. The last question states that the equation of ax squared minus 5x plus 6 has a double root for some value of a. What is that root? Double root means, what does it mean? Double root means two identical roots, right? So we need to check the determinant. Which is usually denoted by delta. So delta is b squared minus 4ac, right? When b squared minus 4ac equals 0, then we will have a double root, right? So b squared is 25. 4ac is a, and c is 6, right? So we let the determinant be 0, then we have 25 equals 24a, right? Then a is actually 25 over 24. And then we can use quadratic formula to get the roots. So x is the 2a's here, and then minus b, and negative or positive square root of b squared minus 4ac, right? So remember that we have already let b squared minus 4ac 0, so this part is 0. That means the double roots is negative b over 2a, which is negative b is negative 5, right? And 2a is twice of 25 over 24. And this is 5 over 2 times 25 over 24. 2 cancels with 24. This is 12. And 12 flipped to the numerator position. And then 5 canceled with 25 leaves you 5. So the final result is 12 over 5, right? Okay, any questions? Any questions? Okay. I'll upload my notes onto Google Classroom. You can check my notes there, and I'll let you know when the next assignment is available. Okay. Okay, first I'll upload for Zora. Okay, it's up there, and then for Emily. All right, if you don't have any questions, you're free to go, okay? Take care.